Today I'd like to take you through how to add and subtract rational expressions. We're only going to focus on rational expressions that already have a common denominator. In this first example, like I said, we already have a common denominator and we want to add these two fractions together. When you already have a common denominator, you can go ahead and write that denominator in your answer. The denominator is not going to change. You're only going to be adding the numbers that are in the numerator. When you are adding two numerators together, none of your signs are going to change. So you can just write all four terms in the numerator, and then you can look for things that will combine. Two terms will combine if they are considered alike. So what makes them alike? They have the same variable raised to the same exponent. When we combine like terms, we're combining their coefficients. So 1a plus 1a will result in 2a. If I combine negative 3b with negative 1b, I get negative 4b. Now, before you finish up, you do need to double check and make sure that you can't reduce this fraction any further. So what are you looking for? Do all of the terms in this problem have something in common? It's an all or nothing type of thing. If they're all divisible by the same thing, then you need to go ahead and do that. All three terms in this problem are divisible by 2. 2 goes into 2 one time, 2 divides into 4 twice, and 2 will go into 20 10. I don't have a common variable, so I don't have to worry about dividing that out. Let's go ahead and write our final answer. 1a. I don't have to write the 1 since it's a coefficient. I can just write the a. Minus 2b over 10a squared. In example 2, we're going to look at two fractions that are being subtracted. There is a difference in how you'll go about setting this problem up. As far as the denominator, since they already have a common denominator, we'll go ahead and write that down. Because these two fractions are being subtracted, this minus sign does apply to every term in the numerator behind it. So we need to make sure and distribute it to these terms as we write them in the numerator. The u plus 5v will remain the same. Now it's time to combine our like terms. And just like before, if they are alike, I'm only going to add the coefficients in front. So 1u and negative 1u are actually going to cancel each other out. Positive 5v and negative 3v will result in 2v. Now, before we circle our final answer, let's double check that we can't reduce this fraction any further. Anything on the top can be canceled with anything on the bottom. And since both of these are monomials, I can cancel the individual terms. 2 divides into 2 one time and into 10 5 times. This 1v will cancel out one of these v's and it will leave a v in the denominator. The only thing left in the numerator of my fraction is a 1. My new denominator is 5 u to the 4th v. This next problem is very similar to the first. It's an addition problem. But the main difference that you'll see is the denominator has a binomial in it. They're the same, so I can go ahead and write down this binomial in the denominator of my answer. I'm going to combine the terms that are in the numerator. And since it is an addition problem, I don't have to change any of my signs. Now let's put things together that are alike. 2a and 4a is 6a. Positive 2 with a negative 2 cancel each other out. Now don't forget, let's look and see, do these three terms have something in common, something that can be canceled out? All three of these terms are divisible by 2. 2 will go into 6 3 times, 2 will divide into 2 once, and 2 will go into 8 4. Something else that all three terms have is an a. So if I take this 1a away, and I take 1 away here, I'm left with a squared. And if I take 1a away here, I'm left with a. This means that my final answer is 3 divided by a squared plus 4a. Sometimes you'll see an equivalent expression where they actually will factor the terms in the denominator. So it could also be written as 3 divided by a, since they have an a in common, and when you divide that out, you get a plus 4. I want to show you one more way to add and subtract rational expressions using factoring to help us with this process. Sometimes when you have a binomial or trinomial in the denominator, it is beneficial to go ahead and factor that binomial or trinomial. Now we know these are the same, so we're not going to have to worry about changing anything, but it might be good to know what the parts are. Both of these have a 3 in common. And so if I divide the 3 out, I'm left with p squared plus 4p plus 3. This factors into p plus 1 and p plus 3. I know this is the same exact trinomial, so it's going to factor exactly the same way. I'm going to use this factored form denominator to help me with knowing if anything will cancel. In the numerator, it is a subtraction problem, so I'm going to distribute that negative sign to both of these terms that follow it. So I've got a 2, a negative p, and a negative 5. When I combine like terms, I'll get a negative p and a minus 3. When I look at the factored form of my denominator, I notice that there is a similarity between what's in the numerator and this particular factor. If I was to divide out a negative, because they both have this, I would get positive p plus 3. Now I can cancel top to bottom. My final answer is negative 1 over 3 times p plus 1.